Let's go over the formulas and steps that you can follow for finding the volume of a solid of revolution using cylindrical shells. A solid of revolution is obtained by rotating a region in the plane about an axis or a line. Let's first go over the formula for rotating a region about the y-axis. In this first diagram, we have a region that sits on the x-axis. When we rotate this region about the y-axis, we get a solid of revolution that has cylindrical shell cross-sections. The volume of this solid of revolution is equal to the integral of this cross-sectional area from x is equal to a to x is equal to b. This cross-sectional area is a rectangle. You can think of it as the label that's wrapped around a cylindrical can. The width is equal to 2 pi r, that's just the circumference of the circle, and then the height is equal to h. If we look back at our diagram, you can see that the radius is going to be x and the height is going to be y, so our cross-sectional area is just 2 pi times x times y. The volume for the solid of revolution can then be found using this formula. It's equal to 2 pi times the integral from a to b of xy times dx. The thickness of each shell is dx. In our next diagram, we have a gap between the region and the x-axis. When we rotate this region about the y-axis, we also get a solid of revolution that has cylindrical shell cross-sections. The cylindrical cross-sectional area is still 2 pi rh, and r, the radius, is still x, but now the height, shown right here, is going to be the top curve minus the bottom curve, and then we still have a thickness of dx. Let's now go over the formula for rotating a region about the line x is equal to a. A line x is equal to a is a line that is parallel to the y-axis. The formula for our volume is really similar to the formulas that we just looked at, but now the radius is just written as r, and it is the distance from the curve to the revolving line, and then the height y is the distance from the x-axis to the curve. If the line that you're rotating about lies to the right of the region, the radius is a minus x, and if it lies to the left of the region, the radius is x minus a. You don't need to memorize those formulas if you just draw a diagram for each problem that you're solving and remember these definitions for y and r. Let's now go over the formulas for rotating a region about the x-axis. These formulas are very similar in structure to the formulas that we just looked at for rotating a region about the y-axis, but now the integration is in terms of y instead of x. In this first diagram, we have a region that sits on the y-axis. If we rotate this region about the x-axis, we get a solid of revolution that has cylindrical cross-sections. Just like before, the volume of this solid of revolution is equal to the integral of the cross-sectional area from c to d times dy. The reason that there is a dy is that the thickness of each cylindrical shell is equal to dy. This cross-sectional area is again a rectangle, and it's equal to 2 pi rh, but now the radius is equal to y, and the height of the rectangle is equal to x. This gives us the formula of the volume is 2 pi times the integral from c to d of y times x times dy. In our next diagram, we have a gap between the region that we're revolving and the y-axis. When we rotate this region about the x-axis, we again get a solid of revolution that has cylindrical cross-sections, Everything is the same as the formula that we just looked at, but now what's different is the height. This height is equal to the curve on the right minus the curve on the left. And then everything else is the same. Let's now go over the formula that we need to use when we revolve a region about a line y is equal to b. A line y is equal to b is a line that is parallel to the x-axis. The formula for the volume of revolution is the same as the ones we just looked at, but now the radius is just written as r. If the line that you're going to be rotating about lies above the region that you're given, r is equal to b minus y, and if the line lies below the region, then r is equal to y minus b. If you don't want to memorize those formulas, just remember that x is the distance from the y-axis to the curve that you're given, and then r is the distance from the curve to the revolving line. Since finding solids of revolution is complicated, just to make things easier, I've written down 5 steps that you can follow to solve these problems. The first thing that you're going to do is graph your given curves, and then you're going to find the points of intersection. From the graph, you can determine the value for the radius, or radii, if there's a gap between the region and what you're rotating about. You can then choose the correct volume formula, and then all you have to do is evaluate the definite integral.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.